Hello everyone, my name is Colton, I'm sure you all know. I'm doing my presentation on space, specifically black holes. There is kind of a lot of ground to cover for context, because like if you don't understand certain things about physics, you won't understand anything about this. So I'm just going to get right into it. Einstein's general theory of relativity describes that the speed of light remains constant in a vacuum, and also that no matter who is doing the observing, the laws of physics never change so long as the observer is either moving at a constant speed or not moving at all. So basically us, because we're on Earth at this point, we're moving through the galaxy at thousands of miles per hour. So this applies to us, obviously, which makes sense because if you're moving, you're going to be getting different results. It's called the general theory of relativity because the universe behaves differently relative to where you are in the universe. From this line of reasoning, he deduced that space and time are actually essentially interlaced into a continuous and smooth fabric known as space-time. The easiest way to think about this is, obviously you guys have never tried to meet with someone at a place without having a time, right? And the opposite is true as well. Like you've never tried to meet with someone at a time without there being an agreed upon place. So that's why these are like fundamentally interwoven concepts. In the presence of large objects, such as the sun or other stars, the fabric of space-time becomes warped due to gravity, and this is how gravity acts on objects. So like, for example, the sun, that's the reason the planets move around the sun, because the fabric of space-time is warped into a bowl-like shape, and that's how the planets know to curve around, or orbit. I guess this is what would be called an orbit. So basically, this is for context as well. So this means that according to the general theory of relativity, that if I was to fly off in a rocket ship for like 10 years to a place, like a planet that's near an enormous star, like thousands of times the size of our sun, for example, I would actually age more slowly because time isn't, like I said, this is relativity, so like, sorry, my notes are all scrambled here. So basically, I would be aging more slowly just due to the gravitational forces that are taking place near that planet. This warping of space-time due to gravity is arguably the most natural thing in the universe, but it's also where weird and unexplainable things can happen, some of which still puzzle scientists to this day. So this is how black holes are created and what they can do. When a star dies, one of three things will usually take place. The star will either explode in a massive display of energy. This is known as a supernova. I had images, but I can't read my notes at the same time. You've probably seen images of supernovas online or something somewhere before. The second is the star will implode, resulting in an even greater outward explosion, but will leave behind what's known as a neutron star. These objects are extremely magnetic and can basically destroy just about anything that gets close to it. Thirdly, what can happen is the star will sink down in on itself in an extreme way, so much so that the sheer weight of it squishes down into a fraction of its original size. So this is basically like, this is the starting of a black hole, which this is where the fabric of space-time, if you can imagine like a blanket and then dropping a bowling ball onto the blanket, and then it curves down into a funnel shape. And this is like, yeah, it warps it so aggressively that it funnels down to a point thousands of times smaller than what it was. So this would basically be like taking like the city of Calgary and crushing it into the size of a marble. So this is basically, this is how a black hole starts, and this is where it starts to, because of the sheer density and its gravitational pull, it starts to pull in objects from millions of miles away. Like it's just the most extreme situation of gravity in the universe that we know of. This newly created object is known as a black hole. The event horizon, which is where it's a spherical border, so that's where you see like the dark hole. It's a spherical border that separates the black hole from the rest of open space, which is also known as the point of no return. Once something gets within a certain distance of this space, there is no escape. It's so powerful, actually, that it will actually suck in light, and that's how, if a light beam, I wish I had the images, normally, like, when if there's a massive object, the space-time is curved, and light will actually bounce around stars because of that warping of space-time. Light will bend and go around it, and you can actually see this. You can look this up. There's like images of it online. But a black hole actually just like sucks in light, and light is the fastest thing that we know of in the universe. It travels at 186,000 miles per second, I believe. And yeah, it can't even escape it. So this fact means that the black hole's gravity is technically infinite, due to the fact that nothing travels faster than the speed of light in the light, and is actually still sinking into a black hole. These objects are fascinating and terrifying because we know almost nothing about what happens when you enter a black hole, other than some speculation based on the law of physics. Like I explained earlier, some interesting phenomena occur in the place of large objects in the universe with massive gravity. There are no objects with more gravity than black holes, though. What if you fell into a black hole? Because no one has ever actually seen a black hole or witnessed anything falling into it, scientists can only predict what would happen if you actually fell into one. There are basically a few things that could happen depending on the scientists you talk to and the size of the black hole. When you fall in the black hole, it's in a funnel shape. You'd be squished. So what would happen is you would fall into the black hole and you'd be squished from side to side and front to back. And at the same time, because of the length between your head and your feet is different, you would actually be stretched out. So at first, at first you would just feel like your feet would be falling faster than your head would be. So you would begin to stretch out, and eventually you would snap into two pieces. And then because those two pieces have the same physics happening to them, you would just keep snapping into different pieces while you're being squished. So yeah, 2, 4, 6, 8, 16 just keeps going until you're basically a paste of atoms. And they actually have a word for this. I believe it was Stephen Hawking that coined this term. It's called spaghettification. So basically, yeah, it's like you're being squeezed, like wringing out a toothpaste tube. So going back to relativity, however, it's been theorized that if you were to fall into a large enough black hole, and this is like a supermassive black hole, this like millions of times the size of the sun, it might actually be possible to survive this. You could fall through I knew there was a lot of ground to cover. So basically, if you were to fall into a black hole and survive it, you would actually, because things have fallen in before you, and because you're leaving the universe behind you, if you were to look in front of you, you would see everything that's ever fallen into the black hole, and everything behind you that's ever going to fall in. So if you were falling like this, and then you looked up, you would see literally like your entire universe unfold before your eyes. Like the future history of that universe just unfold. And then you would be, well, you'd die probably, so. But anyways, yeah, that's basically my speech on black holes. I just find them really interesting, and like I said, I wanted to do more, but there's just not enough time. So thanks everyone.